much. Our first speaker today is Miss Janice Willey. Miss Willey is a senior chemist with the Department of War Naval Sea Systems Command, NAVSEA, Quality Program Certification and Oversight Division, O4Q, Laboratory Quality and Accreditation Office. And as a subject matter expert for the DOW for PFAS sampling and analysis, she serves as the chair of the Chemicals of Emerging Concern subgroup of the DoD EDQW and is a member of the Fluorine-Free Foam F3 qualifications team and the Strategic Environmental Research Development Program, Environmental Security Technology Certification Program, PFAS technical team. In her role as a CERTIP ESTCP PFAS technical team member, she helps the DoW identify the best technologies to characterize, treat, and manage the impact of PFAS contamination at DoW facilities, as well as to help guide research focused on advancing our understanding of PFAS and F3 toxicity and behavior in the environment, as well as the development of sampling and analysis methods. She led a validation study of EPA Method 1633, funded by CERTIP. She collaborates with other DoD services as well as Environmental Protection Agency, state, and other regulatory entities on environmental sampling and analysis issues. She is a member of multiple NATO science and technology organizations addressing PFAS-related issues affecting NATO and non-NATO nations. And with that, I will turn it over.
All right. Get the presentation up. We'll be good to start. Not seeing the presentation.
Can you see it now, Janice? I have it shared.
Cannot. Nope.
Yeah, I'm still seeing the agenda, Zach.
Okay, 1 second.
Okay.
Apologies. There we are.
Still waiting to see it. There we go. All right. Go in presenter mode. We'll get started. Okay. So good afternoon, everybody. I hope everyone's having a great summer. I'm really sorry we weren't able to do a face-to-face this year. That's always fun. Hopefully, like Ed said, we'll be able to see each other next year. So with that, today I'll be talking with you about a PFAS QAPP Worksheets Toolkit. You can get the next slide. What is this exactly? Well, the toolkit is an aid to project teams which provides guidance on how to fill out UFP QAPP worksheets for projects that are conducted for PFAS investigations. It does not include all of the required worksheets, only those that contain information related to sampling analysis, verification, and validation. Not only do the templates include general guidance, include the optimized worksheets. They all include it in the optimized worksheets. They also include quality control criteria presented in Method 1633, the QSM version 6.0, the DoD EDQW data validation general data validation guidelines, and the DoD EDQW data validation guidelines module 6. In addition, the EDQW has also included information and recommendations for consideration. These templates are meant to be used by private contractors performing, keep there on slide 3, performing PFAS impacted media investigations on behalf of DoD under Method 1633, as well as DoD entities performing PFAS investigations in-house. These worksheets are templates They cannot be copied into work plans as is. Definitely not. Project-specific information is required to be added to these templates for a project. Also, due to frequent changes associated with PFAS investigations, project teams are advised to verify and include any updates to referenced guidance documents, memorandum, and methods included with these templates. Additionally, the project team is encouraged to include any project or program-specific requirements requested within the contract's performance work statement. So off the top of my head, one example of an update that will most likely impact the information on these templates is the finalization of the method update rule that's expected to be published this year. If method 1633 is included in the final rule, the method has to undergo some changes as required by their program. So we can expect method 1633 requirements to change. So that would be method 1633. So we use a color font scheme to indicate categories of information. Minimum recommended requirements are presented in black. Green text provides instructions and guidance when completing each worksheet, and blue text provides examples of types of information typically needed. Green and blue text, go back please, thank you. Green and blue text should be removed. We're going forward. Can we go back to slide 4? Okay, I'll tell you when to advance. Guidance examples and minimum recommended requirements contained in these templates are based on the current method 1633 analytical requirements and the QSM version 6 table B24. Data quality indicators may not be applicable to every investigation. Templates should be modified as needed to suit specific needs and project-specific DQAs. However, project teams must provide the rationale for changes to the black text. Again, the tool does not include all required QAPP worksheets, just those that contain information specific to PFAS. So which ones do we include? We can go to the next slide. We included 10 of the optimized worksheets. So today we're going to go through each one of these. For worksheets that we recommend creating separate worksheets for each matrix type, we created templates for each of the matrix types. Due to time constraints today, I have to pick one of the matrix specific templates to go over with you for each of those examples. And go to the next slide. We start with worksheet 12, Measurement Performance Criteria MPCs. Here are the quantitative MPC in terms of precision bias sensitivity for both field and laboratory measurements. A separate worksheet should be completed for each type of field or laboratory measurement. In addition, for PFAS, dividing worksheet 12 into separate worksheets according to group matrices with identical QC parameters such as groundwater, surface water, wastewater, landfill leachate, soil sediment, biosolid tissue, and AFFF or fluorine-free formulations, if needed, is recommended. And go to the next slide. For sample container contamination, in addition to method acceptance criteria, we recommend documentation of this verification be sent with containers from the lab and retained as project documents. The DoD QSM requires the verification of supplies that could affect the validity of the results to occur prior to use, so requiring the lab to provide this documentation should not be an issue. This is also a recommendation through the ITRC documents as well. For field and equipment blanks, the maximum allowable detections, number of allowable concentrations should be stated. We recommend no analytes detected greater than 1/2 the LOQ as the MPC starting point. However, if screening or action levels are less than LOQ, then more stringent values should be considered. Go to the next slide. Source water blanks, you will see, have the same guidance as the field and equipment blanks. Additionally, the project really needs to define what PFAS-free water means to that particular project. The method blank MPCs come straight out of table B24 of the QSM. And again, if the screening or action levels for the project are less than LOQs, the project should be considering more stringent values most likely. We can go to slide 9 now. For LCS and low-level LCSs, we recommend only providing this criteria on one worksheet. Typically, it's either worksheet 12, 15, or 28. This table should reference the specific worksheets they are contained in if they're not contained here. Matrix duplicates are not required by the method, but are required by Table B24 for AFFF or F3 samples. However, projects may choose to include them for other matrices. The MPC in this table for the matrix duplicate is taken directly from Table B24 of the QSM. Matrix spikes and matrix spikes duplicates are not required for the, by the method or Table B24. However, again, a project may choose to include them, in which case the MPCs used for the LCS and low-level LCS must be used. And again, this information should be included in only one worksheet, and that worksheet should be cited in this table. Go to the next slide. We've divided requirements for field duplicates into two categories, aqueous and solids, and have provided guidance based on data validation guidelines. We've provided guidance for all three of the possible situations. So when both results are detected at concentrations greater than LOQ, when one or both are detected at a concentration below the LOQ, or when one result is non-detect. You can go to the next slide. And here are the recommendations for the solid duplicates. As you can see, they're very similar to the ones that were in the previous slide for the aqueous samples. You can get the next slide. Next up, we have representativeness. We're talking about field turbidity measurements. We recommend a turbidity value of less than 100 NTU as a threshold to launch follow-up action by the project team and laboratory. The project team should determine the maximum acceptable turbidity and collaborate with the field team to establish an SOP for recording and communicating results that exceed the acceptance criteria. It's advisable to require the field team lead contact the contractor project chemist when high turbidity values are encountered, and require the project chemist to notify the laboratory PM, the data validator, and the data usability assessment team. The project must document at a minimum as a footnote on the aqueous 1633 worksheet worksheet 12 table, but it also is encouraged to include the information on worksheet 11 as well for further discussion. Next slide. Next up, we have TSS. Here, the project will include project-specific acceptance criteria for the lab TSS analysis. If a project could have samples with TSS levels greater than the recommended 100 milligrams per liter limit stated in the method, they should coordinate with the laboratory and establish an SOP for preparing and analyzing such samples, or review the laboratory's existing procedure to ensure their existing procedure is acceptable for the project. The procedure that is agreed upon must be documented at a minimum as a footnote to the aqueous method 1633 worksheet 12 table, but is encouraged also to be discussed in worksheet 11 as well. Next slide. As far as completeness is concerned, the MPCs for the reported sample data should reference worksheets 34 and 37. The completeness percentage should be stated in the performance work statement. If not, the percentage should be decided by the project team. The QAPP should include the methods and formulas for calculating data completeness, describe how the amount of valid data will be determined as a percentage of the number of valid measurements that are specified in the QAPP for each matrix, analyte group, and concentration, and also describe how critical data will be assessed for completeness when certain sample locations or analytes or matrices are more critical than others in making project decisions. Next slide. And lastly, applicable worksheets should reference the MPCs for sensitivity, the worksheets for sensitivity limits, preservation holding times, ion abundance ratios, instrument sensitivity checks, NIS and EISs. And those will be 15, 19, 30, 24, and 28 worksheets. Next slide. Okay, that's it for worksheet 12. Let's move on to worksheet 15, project action limits, lab specified DL, LOD, and LOQs. This is one of those worksheets I talked about in the beginning of the presentation, that individual worksheets need to be created for each sample matrix type since the limits are matrix specific. The quantitation limit goals should be lower than the PALs by the amount determined by the DQOs. If a PAL is below a DL, LOD, and LOQ, the project team should at a minimum be discussed in worksheet 15. If a non-detect will be reported associated with sensitivity limits above the PAL, then how the non-detections will be used for risk assessment and decision making should be discussed in worksheets 11, 15, and 37. Also, if a contractor adjusts the RSLs for surface water use, then they have to be justified. They have to justify the method that they use to adjust those. All analytes in the Assistant Secretary of Defense 2025 memo on investigating PFAS within DoD cleanup programs are included in the template. Some may not be applicable as determined within the conceptual site model, but the inclusion here gives QAPP reviewers information needed to streamline the review. Go to the next slide. As discussed in multiple DoD policies, DoD project teams have the flexibility to choose their own analyte list for PFAS investigations based on their conceptual site model. We all know laboratories use different variations of target analyte names and or abbreviations than what is used in actually the method. We suggest the team provide the variation in parentheses for ease of verification and validation between the UFP QAPP and the data report for the validators. When filling out this worksheet, project teams should explicitly consider whether a project action limit or a project screening level is the appropriate term depending on the current phase of the project. And lastly, additional target analytes that are critical to project decision making should be highlighted. You can go to the next slide. For preliminary assessments and site investigations, PAL should be based on the memo I previously mentioned. The memo includes RSLs for two analytes not included in the method analyte list for 1633, TFSI and PFPRA. If either of these analytes are deemed to be pertinent by the conceptual site model and DQOs, the analytes can be added to method 1633, provided the contract laboratory has been DoD ELAP accredited for those analytes via that specific method. You can go to the next slide. And here's an example of an entry on the worksheet 15. Although not explicitly stated in this worksheet, given the purpose of the worksheet, it's basically to ensure the selected lab and the methods can provide accurate data at the PAL. It may make sense that the worksheet 15 should be completed for the backup laboratory as well. I've seen some situations where the primary lab met the PAL and the backup labs did not, and you definitely do not want that situation for your project. So that's just a thought. Go to the next slide. Okay, let's move on to the optimized worksheet that includes information that was contained in the original worksheets 19 and 30. This worksheet is a reference guide for field personnel and serves as an aid to complete the chain of custody form and shipping documents. A table should be completed for each laboratory that will be used. If the laboratory is required to be accredited for the project team must verify the laboratory maintains accreditation status for each analyte matrix method combination as applicable throughout its involvement with the project. If the accreditation expiration dates are the same for all of the entries, then a global expiration date can be added at the top of the table. All right. The appropriate sample volume should be determined by the project, not the laboratory. The project must ensure both the primary and backup laboratory utilize the same sample volume identified by the project. This has created some problems in some past projects when that doesn't occur. The project team needs to verify that their laboratory's storage, what their laboratory storage temperature requirements are for their 1633 samples, as well as for their extracts, and enter those storage requirements into the worksheet. This will facilitate accurate evaluation of holding times and sample preservation during the data validation process. For this reason, it's critical that a project also make sure the backup laboratory will follow the same protocols. Another point to consider when deciding which storage requirements will be required for the project is the laboratory's on-time performance and the time of year the samples will be received by the laboratory. The project should choose the storage requirements that best suit their project, and in the end, it's project decisions. They may want to choose storage requirements that ensures the longest holding times to reduce the potential for exceedances, especially during the seasons where labs are most busy. And there's an increased potential for exceeding the shorter hold times. Next slide. Each worksheet should include the name, sample receipt address, point of contact, email, and phone numbers of both the laboratory and backup laboratory, as well as the required accreditation, as well as identify the sample delivery methods that will be used. Next slide. This template includes information for all sample types. However, due to time constraints, I'll just go over those relating to groundwater and surface water as an example. The table should include the method required and identify the SOPs used for preparation and analysis. Anytime I mention SOPs throughout these templates, the revision identifier should also be included in that identification. Required accreditations and their expiration dates should also be listed. The container requirements come directly out of the method. However, as noted, alternate volumes can be used. The use of alternate volumes must follow the DoD EDQW memorandum for EPA Method 1633 sample volume modifications. This memo states the sample volumes collected and used for preparation and analysis cannot be lower than 100 mils. Exceptions to this volume minimum are allowed only when historical data indicates the sample sources contain very high concentrations of PFAS. And very high concentrations of PFAS is not a subjective term. It is defined as the concentration that when a 100 milliliter collected sample is prepared would require the extract to be diluted to the extent their requirements for sample dilution per the method, section 15.3, are not met. Next slide. We all know, hopefully, that groundwater and surface water does not require chemical preservation for PFAS. The project team needs to identify the temperature at which samples will be stored. We provide the options listed in the method in this table. We strongly recommend the colder storage requirement of less than or equal to negative 20 degrees C for due to the greater potential for transformation to occur at 0 to 6 degrees for some of the analytes. Since options for preparation holding times are listed in the method and included in the template, the project team needs to select the applicable holding times based on the preservation requirements they selected. Per the DoD EDQW memorandum on recommendations to address shorter holding times, when stored at 0 to 6 degrees, it's recommended that the project team document in their DOQOs whether the shorter holding time shall be met or if estimated results for those analytes are acceptable per their intended data use. Projects should discuss their project-specific requirements with their laboratory and backup laboratory and potential costs associated with meeting the shorter hold times prior to submitting samples for analysis. Next slide. And lastly, we have two options. We listed two options provided in the method for the analytical holding times. The project must select which option will be required. We also provide guidance for qualifying data when the 28-day hold time for two of the analytes are not met based on the previously cited memo, which states that the DoD does not expect the laboratory to meet the 28-day hold time. However, the laboratory must qualify the results for those two analytes in either the case narrative or alongside the sample results in the report. And the project team needs to document the turnaround time requirements for the data packages on these worksheets as well. All right, next slide. Next up, we have worksheet 20, the field quality control summary. It provides a summary of the types of samples included in the project, showing the relationship between the number of field samples and associated QC samples for each combined analyte analytical group, and matrix. The number and type of QC samples must be based on project-specific DQAs, and this worksheet should be adapted as necessary to accommodate project-specific requirements. Not all types of QC shown in the examples will be necessary for all projects, and some projects may require additional QC samples like proficiency testing samples, which can be listed in an other column. Next slide. Samples that are collected at different depths at the same location and analyzed separately should be counted as separate field samples, even if they are taken from the same container as parent field samples. Matrix spikes and matrix spike defects are counted separately because they are analyzed separately. Next slide. Again, due to time constraints, I can't present the information for all the matrices, so I'm going to just pick groundwater as my example. The number of field samples and matrix duplicates to be collected during the project need to be documented. The field duplicates are to be collected 1 per every 10 field samples at a minimum, according to the DoD Environmental Field Sampling Handbook. For example, for my example, I decided that no MSMSDs will be collected. However, we state inclusion of MSD samples is a project-specific decision and should be clearly reflected in worksheets 12, 20, and 28. Next slide. Trip blanks are not required for PFAS groundwater sampling. Here we provide the requirements for field blanks, equipment blanks, and source waters that are stated in the DoD Field Sampling Handbook again. And lastly, the project should document the total number of analyses for that matrix. Next slide. On to worksheet 23, analytical SOPs. This is an easy one. This worksheet documents the specific sample preparation and analysis procedures to be used. The SOPs for all sample prep and analysis must be current and referenced whether these activities are performed in the field or in an offsite laboratory. If this information is not known at the time the QAPP is being prepared, it's acceptable to enter TBD for the required information. However, the worksheet must be completed before the QAPP is approved. If required by the project, copies of the SOPs should be included as hard copies or electronic appendices. The project team should review all SOPs to make sure they are either sufficiently prescriptive to be implemented as written or modified as necessary for the project. Again, I also recommend inclusion of this information for the backup laboratory as well. Next slide. And here's the template. It's pretty straightforward. Blue is obviously example. Okay, next slide. Next, we have worksheet 24, the analytical instrument calibration. This worksheet should be completed for all analytical instruments, whether used in the field or at the laboratory. We included information relative to the analytical instrument only in this template. As appropriate to the instrument, calibration procedures should include tuning, instrument calibration blanks, instrument calibrations, initial calibration verifications, if required, continuing calibration verifications, and verification of detection and quantification limits. If information for a specific procedure is provided in an SOP, the SOP is attached, then the worksheet can reference the SOP and identify the responsible person. Next slide. So as you can see, we have transcribed the requirements from the method or table B24 into each of the applicable columns, with the exception of the SOP reference, which the project needs to identify again with the revision identifier as well. For the rest of the worksheets, I will not go, I'm not going to restate all of the method and table requirements to you. I'll focus on items we added additional guidance to, but rest assured we've included all of the required elements in the template. Next slide. We added some guidance with respect to ion transitions, which essentially says the laboratory if the laboratory uses alternative ion transitions as stated in their SOP, they would have been evaluated with respect to the QSM requirements during their DoD ELAP assessment. These alternative transitions must be provided to the project team and must be approved by the government project team and recorded in the QAPP. There may be some projects that need to utilize the ion transitions from Table 10 of the EPA method. Therefore, it's ultimately a project decision whether alternative ion transitions are acceptable for the project. Next slide. We've also included the ICV just in case a project decides or needs to require an ICV. Next slide. As far as the ISC is concerned, we added some information based off of the DoD memo on method 1633 sequence requirements. This memorandum allows for the ISC and the CCV to be alternated every 10 samples throughout the analytical sequence. That's different than what is actually written in the method right now. This is something that the EPA and EDQW agreed on. This worksheet needs to document, though, the specific analytical sequence scheme the laboratory will use in accordance with their SOP. Next slide. And again, the same guidance from this memo is provided for the CCV as well because it applies to the CCV as well. Next slide. The last item we added was for the qualitative identification standards. This was just to clarify that these standards are not required for those analytes where quantitative standards that are discussed in 1633 already exist that contain Branston linear isomers. This is because since the method was published, additional quantitative standards have been created by manufacturers. We kept this in because we know more and more standards are becoming available, and also laboratories are adding more and more analytes to their 1633 scope of accreditation, and this requirement would apply. If there was a qualitative standard out there for those additional analytes, you are required to include that as well. Next slide. Okay, next up we have worksheet 25. That's the analytical instrument and equipment maintenance, testing, and inspection. Project teams need to determine whether it's necessary to complete all fields in this table. For example, if the selected laboratory is operating under a quality system that conforms to ISO 17025, then the activities documented in this table will be documented in the laboratory's quality manual most likely. In this case, it may be acceptable just to simply reference the quality manual, including the revision number and date. However, if the project has specific requirements that are different from those contained in the laboratory's quality manual, then this table should be completed for those items. Next slide. As you can see, we populated the table with the standard maintenance activities associated with an LCMS-MS. You know, we have backflush of the column, injection port and pre-column, cleaning of the ion spray cone, and adjustment of collision energies. Testing activities are, calibration check, inspection activities is visual and is free, and the frequency is as needed. The acceptance criteria for the calibration check is as required by the method, and additional maintenance prior to instrument calibration and calibration verification if the criteria is not met. The project must identify the responsible person as well as identify the laboratory's SOP, again, including the revision identifier. Next slide. Next up, we have worksheet 28. The purpose of this worksheet is to ensure that the selected analytical methods are capable of meeting the project-specific MPCs. A separate worksheet for each sampling technique, analytical method SOP, matrix, and analytical group should be prepared. It's also recommended that worksheet 28 is divided into separate worksheets according to the group of matrices with identical QC parameters. So that would mean groundwater, surface water, wastewater in one, landfill leachate in one, soil sediment in one, biosolids in one, tissues in one, and then AFFF and F3s in one. Of course, we have created a spreadsheet for each of these. To me, worksheets 24 and worksheets 28 are the reasons for why we really created this toolkit. As you know, all other table Bs in the QSM contain all of the analytical instrument calibration and quality control requirements that are associated with the field of testing. Since table B24 is specific to a method, the EDQW opted not to go this route, and we only included items that are unique to us. And not included into in the method. For example, requirements pertaining to AFFF samples, as well as items that require different criteria in order to be compliant with the general requirements of the QSM for chemical analysis. As a result, we've been getting in QAPPs that are far from complete, often only including those items that are actually listed in the QSM. So yes, we've included a template for each of the matrices again, which includes all of the QC samples that are required by the method in table B24 for that method. So if you know the method in table B24, you know what's in these tables. Again, I'm only going to focus on one matrix. I'm going to do the aqueous, the groundwater, surface water, wastewater, and highlight those items that that we included additional guidance added to the template. Next slide. For acceptance criteria associated with the method blank, again, we noted that if the screening or action levels are less than LQAO, you need to consider more stringent values. Next slide. The LCS, and if required, the LCSD. We added the LCSD because we know that some projects still like to include the LCSD in their projects. So we've just included that, but everything else in this table is straight out of the method and the table B24. Next slide. Same goes for MS and MSD. They're not required. Some projects like to include them, so we included a line item for those as well. Next slide. And matrix duplicate, again, not required for aqueous samples, only required for AFFF and fluorine-free samples. But some folks like to include them, so we added into this table as well. Next slide. EIS, alternative EIS compounds may be used per the method to improve performance. We know standards providers have been working hard on developing alternatives for some of the more problematic ones we identified during the method validation. This can be a confusing situation for the project teams. Some project teams are hesitant to use a lab that uses alternative EISs because they think it's their responsibility to ensure that they meet all of the stipulations for alternatives outlined in the method. This is not the case. To clear up this misunderstanding, we added a note to this table stating that it's the responsibility of the accrediting bodies within the course of the laboratory's DoD ELAP assessment to evaluate the use of alternative EISs and ensure that the method requirements stated in Section 9 are met. But again, in the end, it is the project's decision. There may be some situations where they are required to utilize a specific those EISs specified in the method. So that's something that definitely needs to be considered. Next slide. And the same goes with respect to the NISs. So we added a similar comment to that as well. Next slide. Okay, we're in the home stretch. We have just 2 more worksheets to go. Worksheet 34 is the data verification and validation inputs worksheet. It documents the inputs that will be used during the data verification and validation processes. These include things like project planning documents, field records, and the laboratory records. Data verification is a check that all specific activities involved in the collecting and analyzing the samples have been completed and documented, and the necessary records are available to proceed to the validation step. The validation step is the evaluation of conformance to stated requirements, including those in the contract, methods, SOPs, and the QAPP. The actual inputs required should be based on the graded approach as defined by the project planning. Next slide. The items that only apply to verification are these first four: approved QAPP, contract, field SOPs, and laboratory SOPs. Next slide. Those that require verification and validation, are all these, and keep on going to the next slide. All of the analytical data package required elements that have to be validated per the data validation guidelines are also included. So we can go to the next slide. And as you can see, we've included them all for you. Next slide. All of these items, like I said, correlate with items listed in the PFAS DVGs. Yes, there are some summaries that are not typical to data packages for other analyses, like sample ion ratio summary or transition ion summaries, but all of these summaries are needed in order to efficiently validate all of the requirements of the methods and the project. Without these, the validator's job becomes much more difficult and also much more time consuming. Next slide. And last up, we have worksheet 36, data validation procedures. You're going to hear a lot more about these today, so stay tuned. This worksheet documents the procedures that will be used to validate the project data. If data validation procedures are contained in an SOP or other document, they should be referenced in this table and included as an attachment to the QAPP. The validation codes and label identifier table, as well as any checklist to be used, should also be attached to the QAPP as well. Next slide. So here's an example of, and this is just, remember, blue is just an example, right? We have what level the data package is and what form it should be in, where the analytical specifications can be found, where the MPCs are documented, what percent of the data package is to be validated, the percent of raw data to be reviewed, the percent of results to be recalculated, frequency defined for each, the validation procedure to be used, the validation code to be used, and the electronic validation program or version. Next slide. Any data qualifiers to be applied to the data by the valid validator must be defined. Of particular importance, third-party data validation should not include the rejection of data, noted by an R. Data validation should note when performance criteria are not met, but the final rejection of any data and their use is a decision reserved specifically for the project team. Next slide. And lastly, this worksheet provides the validation codes and label identifier table, as well as any checklists to be used and should be attached to the QAPP as well. The example provided made use of the terminology contained in the guidance for labeling externally validated laboratory data for Superfund use, which was developed to promote the use of consistent terminology by an external data reviewer. More to follow, definitely, on data validation. I've got a lot of really great presentations coming your way today on that. And next slide. Well, there you have it. That is your worksheet toolkit for PFAS. I'll thank you for all of your attention. I know I went through it really fast, and I'm not sure if we have any time for any questions. I see a question about worksheet. Are they available right now? They are not available right now, but they will be shortly. We are in the very final stages of of finalizing them. They've gone through multiple comment periods, and when they are available, they will be at least available on the DENX website.
We have about 5 minutes left, so Janice, if you want to answer another question, pulling those up on my end.
Okay.
Teams is just being a little slow.
Gotcha. Yeah, there's quite a delay today. Apologize for that, y'all.
I am unable to open the Q&A.
Zach, this is Nancy. I can open the Q&A. Oh, did we lose Zach?
Apologies, I'm here. I was muted. But yeah, if you wouldn't mind to read one, we have 5 minutes, like I said. So let's read one question off. And again, for anyone, our questions are going to be compiled today, so we will get an answer to you.
Okay, we have a question. Would you clarify what constitutes third-party data validation? The DoD data validation guidelines state that only the validation should be performed by someone other than the laboratory. However, it is often interpreted as meaning the data validator cannot, or the data validation cannot be performed by the main contractor, but must be subbed out.
Nancy, you're, well, I mean, that third-party data validation, it has to be other than the laboratory. That's basically what that.
Melinda is
Go ahead,
raising
Melinda.
her hand.
Yeah, hey, so that's actually a great question because I get that question all the time talking about data validation guidelines. So there's a lot of discussion about it, but I think it's in the general data validation guidelines, we basically say that what we mean by third party is the laboratory isn't validating their own data. We then identify what we called I think we called it a government QA validation or something. I don't remember the exact terminology, but that's the idea that the validation is not even associated with the prime contractor. So the government separately contracts validation, like completely separate from anybody, responsible for the generation of the data in any way. I don't actually see that happening all that often. The two most common things that I see are that the validation is performed in-house by a chemist at the prime contractor, or that the prime contractor subcontracts to a validation firm.
Yeah.
Those are the two things that I see.
I think what you're saying, though, for that, Melinda, is that basically the real answer right now in practice is third party means not laboratory.
Right. Absolutely. Yep.
Yeah. And I know that there was a question in the chat about, will we be notified? Can we be notified when these are available? Absolutely, they will be. We will send out notice to everybody that they have been placed on the DENX website, and as Denise put in I think the comments, flung far and wide, so everybody can use them.
All right. Well, thank you so much, Janice, for that wonderful presentation. And again, we'll get to the questions. We're going to compile those and get answers, and then we'll post those along with the recording of this webinar.